All right, so in this video, what I'm going to do is I'm going to effectively wrap up our conversation about pollution, and I'm going to specifically talk about the issue of water pollution. A lot of the discussion in environmental economics with regards to pollution ends up focusing a lot on air pollution. And there's a number of reasons why we tend to focus on air pollution. One, for better or for worse, people care a lot about air pollution. Now, obviously, people caring about air pollution, that's inherently a good thing. But what's interesting about air pollution is that there is a real sense, I think, amongst uh, environmental scientists as well as environmental economists, um, that we tend to care more about air pollution than we care about water pollution. And that does not in any way, shape, or form mean that water pollution isn't as big, if not even perhaps maybe a bigger issue than air pollution, especially when it comes to developed economies such as the US. In many ways, I think people are aware that in developing economies, are still trying to get their economic feet underneath them, that those countries are really churning up their environment. And to some normative sense, that's acceptable to us because, look, it would be weird for us to have churned up our environment, got all of that great economic growth, made all of those societal strides, and then turn around and tell poorer countries who are in the process of developing their economies, no, you can't grow your economy the way that we did, and then therefore you're not going to get access to all the great things that come with economic growth. I think one of the reasons why people tend to look past that sort of issue is there's a belief that if there's some technology or some process in the US that is cleaner and less environmentally damaging and does not take away from economic growth, then that technology or that process exists everywhere. And that's simply not true. There's a really important concept in globalization referred to technology diffusion. And technology diffusion means it often takes a while for technology to spread about the globe. And so the United States has access to technology and processes that developing countries simply do not have access to. And so as a result, this brings up interesting sort of moral dilemmas. Do you hold developing economies to a higher standard than you held yourself when you were developing? And that I think is something that we'll come to a little bit later in the semester because there's a lot of interesting things there. But I think people are sort of aware that in developing economies, there's a lot of air pollution, there's a lot of water pollution. Sort of famously, if the air pollution problems in China, people like to show photos of Chinese, smog problems and air pollution problems that are visible. People like to show pictures of like the Ganges River in India, which is very polluted. And in a way, it's sort of an example of the detriments of globalization, right? Because people sort of tend to believe that China wouldn't have bad air quality if it wasn't for developed economies consumption. That India would have far less water pollution if it weren't for developed economies consumption. And those two countries obviously produce a lot of goods for the global economy. And so in a way, it's almost like there's an acceptance of pollution there. Not that people don't care about it, but that it's sort of more, we expect it more. Whereas in the US, people sort of expect things to be relatively clean. And the focus has really been on air pollution for a long time. And partly because we've cared more about water pollution, but also because, as we'll discuss in this lecture, the issue of water pollution is very tricky. It's actually a very difficult thing to sort of wrap our heads around from a policy perspective, and perhaps even more difficult to wrap our heads around from the perspective of there's so much water, surface water as well as subsurface water, that it's extremely difficult for us to basically have a working economy and keep our water clean. It's a very difficult task. And so, as is often the case, things that are difficult to do, you don't get a lot of that often. And so, water pollution has definitely been something that the U.S. has continues to struggle with, and will likely continue to struggle with, in the near future. All right. So the first thing we have to sort of, keep in mind is that unlike air pollution, water pollution gets into different types of water. So you have surface water, which is like your lakes and your rivers and your streams. You have your groundwater. Now, this is where things get really tricky because with groundwater, there's very little ability for humans to prevent ground water contamination in many circumstances because the water exists below the ground and the ground is permeable. And so chemicals and other pollutants that make it to the ground can often make it to the subground and then eventually make it into groundwater, and sometimes can make it into groundwater in ways that we can't readily prevent. Even if we were aware of it, we can't necessarily prevent it. And this aligns with another very important idea in environmental economics, and that's the difference between point source and non-point source pollution. I remember being in graduate school, and the first time I heard about the concept of non-point source pollution, I was like, wait a minute. There's pollution out there, but we don't really know exactly where it's coming from. We don't have a particular source. That's highly problematic from the perspective of our ability to find the sources and punish them if they're polluting in ways they shouldn't be, or simply monitoring the pollution. One of the things that we talked about in the context of monitoring pollution is, there are often concentrations of pollution that arise from particular point sources. And even if we know where the pollution is coming from, if it's being, if this is pollution that's making its way into a waterway, there's a dilution effect, and it can be very difficult for us to actually measure how much pollution is coming from a particular source. And that highly complicates our ability, therefore, to set cost-effective policy to reduce um, water pollution, or any type of pollution. Now, in the context of non-point source pollution, it's even more difficult because here we're talking about pollution like we can measure it in the water, but we don't know exactly where it came from. We don't know in any way sort of what were the proportions. So a good example of this, so I used to live in the state of Michigan, and the state of Michigan has a lot of farms, and those farms produce a lot of what we would call emissions runoff. And these emissions are a lot of different things. So everything from, antibiotics used in treatment of animals, which can make its way into water systems, the blood and the remains of animals that have been butchered, that can make its way as a pollutant into some sort of water situation. And then, chemicals used in agriculture, whether it's pesticides or other such chemicals. And then, if there's a heavy rain, or really even if there's not a heavy rain, just those pollutants can make their way into water, groundwater, or even surface water. And we don't know really to what extent this farm or that farm is responsible for the particular runoff. So from our ability to craft policy to reduce it, since again, this goes back to kind of there being a property rights problem. We talked earlier in the semester about one of the key issues in environmental economics is that we have a property rights problem. It's sometimes difficult for us to always know who is responsible for the damage and who experiences the damage. And that's definitely true with respect to water. And so, when we talk about like primary sources of water pollution, obviously there's a lot of pollution that makes its way into rivers and lakes. Rivers, for example, have often been a hub of economic activity, whether that's shipping goods across rivers, or whether that's the placement of coal-fired power plants or nuclear energy power plants, or basically factories. There's so many manufacturing processes and energy manufacturing processes that require a lot of fresh water, and rivers become a wonderful way for us to have access to fresh water. And in an almost more of a nefarious way, the fact that rivers flow, this enables companies to dump pollution into rivers, and then it becomes hard to monitor that pollution, and it becomes hard to then regulate. And so there's a reason why if you're around big lakes or you're around big rivers, you'll often see electricity plants right on the river. They need access to clean water, but of course, there's a lot of potential pollution that can make its way into a river or lake in that way. We already just described groundwater. Most groundwater contamination comes from the migration of harmful substances. One of the bigger issues in terms of water pollution that's come up, recently is ocean pollution, in particular plastic pollution. But then, of course, we also have, oil spills, which are always a really big concern. Um, and but in terms of there's always this issue in environmental problems where I think that the things that people care most about are sometimes not the things that are the most problematic. So, for example, people were really, really scared of smog in the late 80s, early 1990s, to the extent that we took on a lot of policy to reduce smog. And I think in part because people could see smog, but we didn't do anything for CO2 during that time. Right now, we know in many ways CO2 emissions is more existentially concerning to us maybe than SO2, which causes smog. But because we could see the smog, it was more psychologically obvious to us that it was a pollutant. Whereas like CO2, we can't really see it. The effects of CO2 come far after those units of CO2 are emitted, and so our eye just wasn't on that particular ball. Um, and so, for example, people are very concerned about oil spills in the ocean or things like that. But the truth is that oil spills in the ocean have been greatly declining over time. This is one due to regulation, but then also due to just the fact that listen, I mean, oil companies don't want to spill oil. That's lost profits. So oil companies have a vested interest in reducing the amount of spills that they incur, and so not just regulation, but also just the profit motive. I think that's sort of maybe the thing that this is an example of a situation where the profit motive actually elicits the behavior you want, but people would not think that. So people might jump to the conclusion that, well, if profits are all oil companies care about, then they're not going to care about oil spills. But the fact of the matter is that oil spills are very costly for the firms, like not just in terms of lost oil, but also in terms of you're going to have the government on your back. You're probably going to have to pay some hefty fines. And so that's I think an interesting sort of point where there are some circumstances where the profit motive elicits pro environmental behavior, and I think oil spills happens to be one of them, which I think explains the great reduction. But people are very concerned about oil spills, even in 2023. And again, I'm not suggesting that oil spills aren't highly problematic. They are, but in terms of those key pressing environmental issues, the things that on a daily basis we should be worried about, oil spills perhaps don't necessarily need to be at the top of the list, because in a way we're sort of taking care of that. And if you look at like oil spills over time, what you'll see is that most of the larger oil spills happened a long time ago. Obviously, a great exception to this rule would be the BP oil spill in 2010. And so it's, again, I'm not saying that oil spills aren't a problem, but they're about a little bit less of a problem than they used to be, which is good. It's, again, we need to make sure we take stock of those environmental gains. So with water pollution, oil spills end up not really being a big issue. We're much more concerned about the other areas of potential water pollution. So just like our previous discussion about pollution, there's stock versus fund pollutants. So with water, there is some capacity to dilute pollutants to the extent that they have really not that much of an effect. If we're talking about like nitrogen being pumped into water, there's a certain amount of nitrogen that can be pumped into water that's not going to really affect the content of the water or the quality of the water. But then if you pass a particular threshold, then nitrogen becomes highly problematic. Nitrogen, by the way, ends up making its way into waterways from a lot of different sources. One of them is runoff from agriculture. Agriculture runoff has a lot of nitrogen in it, highly nitrogen content. And so nitrogen becomes a big sort of pollutant in water. But as long as we keep nitrogen below a certain threshold, it's really not a problem. So with things like nitrogen, um, and other sort of what we might call fund pollutants, again, those pollutants that the earth or the uh, sort of receptacle in question here, we're talking about water, has some absorptive capacity towards those particular pollutants. And then there's also stock pollutants. So I previously mentioned people are very concerned about plastic pollution, especially in the ocean. Plastic is a stock pollutant, and it's a highly problematic, water pollutant. There's other types of water pollution that people tend to not know about or think about very much. Thermal pollution, going back to our example of coal-fired power plants or nuclear energy power plants being located on rivers or lakes. They need fresh water because they need to cool down their machines. Well, their machines create superheated water, and then the companies often, well, at least previously, they would just dump that superheated water back into the river or back into the lake, and eventually the water would come back to its normal temperature, but for some time period, it would have really elevated temperatures, which creates all sorts of problems for flora and fauna, and again, it's important for us to keep in mind that when we talk about disrupting biodiversity, over time, we care more about biodiversity as a society than we used to, but hurting biodiversity is something we should be concerned about, not just for biodiversity's sake, but also because reducing biodiversity can affect humans as well. You previously this semester read the chapter called Noxious Cargo from the book, The Life and Death, or Death and Life, rather, of the Great Lakes, where basically what was going on is you had these ships were unloading their bilge pumps, and these particular species of mussels got into Lake Michigan, and they basically took over and they completely changed the biodiversity of Lake Michigan to the extent that the cash crop fish, the fish that people made money off of by catching out of Lake Michigan, are not really around in the same numbers they were before. And so, again, environmental damage is not just about aesthetics. It's not just about, hurting human health, but environmental damage also eats into companies' bottom lines. Not to say that we should care about that more or the same as we care about human health. I don't think we should, but it's important to keep in mind the damages here aren't just, you made someone have worse asthma, or you killed a bunch of animals, or you decimated a wetlands area, but also that you're hurting people's ability to make a living. And that matters to economists. There's also like pollutants that accumulate and then break down extremely slowly over time. Those pollutants are problematic because they could travel long distances and pollute a lot of different potential water sources. And so, like mercury is a great example of a persistent pollutant. Once mercury gets into water in a particular threshold, it almost never goes away, or at least it requires an immense amount of remediation, often not cost effective. And so in Lake Michigan, for example, there's a tremendous mercury problem on the east side of Lake Michigan, where there are a lot of coal-fired power plants and also steel refineries. The steel refineries get a lot of the mercury into Lake Michigan, and so you can't eat the fish that is in those particular areas. You can't swim in the water. It's not safe for humans to swim in, and so mercury and those problems have been going on for decades. So definitely, mercury would be a persistent pollutant. And then there's things like accumulating pollutants, and these are extremely problematic because oftentimes they're hard to monitor. It can be difficult for us to sort of monitor the persistent accumulating effect of things like mercury, unless we know exactly how much mercury is going into the water. And again, we're in water pollution. It's not always simple to monitor things like that. So just to kind of take you through some of like the early policy, actually we've been concerned about water pollution for a very, very long time. So in 1890, we had the Refuse Act, which was about regulating the discharge into nation's waterways. What's interesting about the 1899 Refuse Act is that it's actually sort of starts out being very stringent. I mean, it's basically like we are going to protect all the waterways in America, and we're not going to let anything bad go into the waterways, which in a way is sort of silly when you think about it. But that in a way that was the goal. Um, 50 years later, or nearly 50 years later, we have the Water Pollution Control Act. So this is the first real federal attempt to regulate water, but in this case, regulating federal waters, right? And so one of the issues with water pollution is that again, it's very much a local problem, and so federal legislation often early on targeted federal waters, waters that were in essence owned by the federal government, and this, of course, very much limited the authority of regulators to actually regulate water pollution. But the other thing that the Water Pollution Control Act did is it set a particular standard towards researching these problems. So we started to care about these problems and much more. So money became available to research these things. And what ended up happening was we realized that, okay, there's a lot of problems. We have a lot of water pollution problems in the US. So less than 20 years later, we have the Water Quality Act of 1965. This was the first one that actually set ambient standards for specifically interstate water courses. And much like we've talked about previously, the way that these policies worked, which is very similar to the way modern EPA policy works, is that states are sort of put on notice that, listen, we believe this pollution is coming from your side of this intercoastal waterway. You need to remediate, and so it falls on the states to do this, which that elicits certain types of behaviors and not necessarily all others. Here's the actual parts of the law that detail specifically the research and related programs, which I think is really interesting. That they crafted these laws not just to regulate pollution, but also to learn more about it. I think that's one of the most kind of least appreciated aspects of congressional law. Is very often not only do we regulate things, but we also try to learn more about them. And that certainly was true when it came to water pollution. So again, we set out the Clean Water Act of 1965 to do two things. Was one, to eliminate the discharge of pollutants into navigable waterways. We wanted to eliminate those by 1985, and that wherever attainable, an interim goal of water be achieved by June 1st, 1983. So real sense here that water pollution is a huge problem. But subsequent to the Clean Water Act of 1965, we've had numerous amendments similar to the Clean Air Act. We see similar numbers of amendments there as well, which speak to, again, over time, we learn more about the legislation, we learn more about the pollutants, and we change the way that we do things. One of the things that the Clean Water Act, especially the 1987 amendment, was that it provided funding for states to learn more and control things like runoff, the so-called non-point source pollution. But again, this was simply up to the states. And so what ends up happening in the context of water pollution is that you have this sort of dichotomous stance. Some states take it very seriously and do a lot to kind of try to maintain their waters. Other states don't do as much. But the problem is, of course, that water is all connected. And so if one state's not doing as much of another, and you get these sort of heterogeneous policy responses, the result is less clean water than you would if there was a homogenization of policies across states. So perhaps one of the things that we could say that's potentially a weakness of the Environmental Protection Agency is that its authority is mostly held through the transmission of policies to the states. But then it's up to the states to actually enact those particular policies. And then the EPA has sort of litigious authority to sue or to punish or to penalize states that don't do anything. So one of the main ways that we think about water pollution is this concept called total maximum daily load. This refers to the maximum amount of a particular pollutant that you can put into a body of water and then still meet water quality standards, and as well as the allocation of that amount to the pollutants resources. I like this picture because this picture does a great job of just showing you how interconnected water tends to be. You see, we have groundwater, we have an ocean, we have a lake, and we have a tributary that goes from the lake out into the ocean. And all sorts of factors here affect the way in which pollution affects the water and then ultimately affects humans, flora, and fauna as a result of accumulations of particular pollutants. Also, one of the things that I mentioned previously in the lecture, but shows up here as being really important, is weather. Weather is very important when it comes to air pollution. Wind speed, rains, barometric pressure affects air pollution. Weather also, of course, affects water pollution, specifically in that rain will cause pollutants to spread out. So basically, every time it rains, you can imagine that there's just a bunch of pollutants that are being moved from where they are currently and being spread out to other locations. So if next time you have a rainy day, not to make things too cynical, but you can think about that. We became especially concerned about drinking water around the 1970s. This goes back to our concern about water tables and groundwater, because a lot of the water that we get comes from groundwater, comes from water tables. And the fact of the matter is that a lot of groundwater, a lot of water tables are prone to a lot of pollution. And so the Safe Drinking Water Act of 1974 was an attempt to regulate specifically drinking water, to pay especially close attention to the sources of drinking water, and to make sure that those, that the regulations on them are tighter than perhaps a water source where we're not pulling it from drinking water. So in a way, what this does is it sort of dichotomizes water. There's like water sources, and then there's drinking water sources. And for obvious reasons, the regulatory tension on drinking sources is higher and more stringent, as you would tend to expect. So one of the things that happened over time is that we shifted from sort of ambient standards to these sort of zero discharge goals, which you can sort of see that as a little bit of like moving from, okay, we want to reduce pollution to we want to get rid of it completely. But this created a lot of sort of problematic, outcomes. First off, the feasibility of meeting zero discharge goals is extremely small. And because of that, enforcement ended up being fairly lackluster. Like if you've ever worked in systems, one of the things you learn is that rules and subsequent punishments have to actually be something that you carry out. But because the zero discharge goal was so difficult to actually meet, there would often just be these carve outs. Well, okay, you couldn't meet that zero discharge goal. That's okay. It's hard to do. And then, okay, so what's the point of the rule, right? So we should just go back to ambient standards, as a result. As is always the case, one of the things I've made an especially important point of this semester is that there are some pollutants that are so nefarious that zero pollution absolutely should be a goal. I've talked about benzene as a particular example. We talked about the Pacific Gas and Electric story with their contamination of groundwater with hexavalent chromium. So clearly there are some pollutants that we don't want any of that getting into water. And so therefore, again, for those particular pollutants, perhaps a zero discharge goal actually is a workable solution. But for those pollutants that, let's say, are near impossible to prevent from getting into waterways, zero discharge goals become extremely problematic and in a way kind of unhelpful. Again, this is where we have to be a little pragmatic about environmental policy, and we have to look beyond intent. The intent is zero discharge, but should that be the intent is sort of the question we want to ask.